Okay, so moving on from DNS attacks, and again, I hope that going through those attacks, I know we went through them quickly because it's important to know them. And you might not think when you're creating your website that we need to start at that level. But again, if we don't understand the whole process of how the whole web has been created, then that's exactly where we become vulnerable to these types of attacks. And more and more again, as we have this tension in the web of we want to create just simple document, right? Just very simple standards that everyone can adhere to. To on the other end, we want to create the web so that it's actually a very powerful platform with many built-in APIs that most applications that we create don't hinder the user. We also have to become aware that with that power, we open up the web to allow more to allow more attacks. Okay, so I think web security in the future is going to become, if not more important than network security, just as important. Just simply because the way the web is moving in a direction that websites are not simple documents anymore, right? They're full-fledged applications, and as computers get even more powerful and a lot more of the processing can happen on the client side instead of on the server side, then we can see how these attacks really can affect a system once someone either has been able to inject some type of code or run some type of code on your machine, on your code base, right? So now that we know the first thing that happens when you type a URL and press enter on the web, let's move on to, which is the first step, is DNS. Then what happens at the HTTP level, right? So we know the DNS and the resolver and the attacks that can happen at that level. But then let's talk about, which is what most of the rest of this class is going to focus on, okay, which is HTTP, and which is the protocol of the web. And pretty much when you write an HTML document, this is where it gets transported from the HTTP protocol, right? So let's go over the HTTP protocol. Let's see how it works, and let's see some of the vulnerabilities that are built into that protocol, and how we can exploit some of them, and then how we can defend against some of it. So HTTP is actually a very simple protocol, and I'm going to go ahead and I'm going to go open up my terminal over here, and what I'm going to do is I'm going to go curl, and we're going to curl a very simple let's just curl let's see here, HTTP as www.twitter.com. Let's see here, did I write that correctly? I put 4 W's, it's 3 W's. Okay, here we go. So whenever we go to a website, okay, it's going to issue an HTTP request over a TCP socket, right? And in that request, if we focus on this side of the request over here, the request is going to be using, it's going to have a few things to make the request happen. And anybody can write a very simple HTTP client, and all you need is pretty much these things here. So you need the get, the type of request it is. This is a get request. Well, we're requesting the path is the path is just the home page, right? So this would be a different path if it was a different home page, if it was a different resource on that domain, and then the version of the protocol. So in this case, we're using the HTTP protocol, and we're using version 2. So you can imagine if we're trying to get a video, it might be different MP4 or something like that, but it's going to become that request is going to come over HTTP as well. And then we actually have to identify what the host is. In this case is twitter.com, and the user agent in this case is curl, but otherwise it would be like Mozilla or Chrome or something like that. Okay, then the response we get from that, it's also very similar. Okay, so I'm gonna make that request again just so we can get the full version of Twitter and not truncate it. And then what we're gonna be going over, so we're over here. So in that response that we got from Twitter, we got a 200 response. Okay, and we did the same thing, curl v and HTTP twitter.com. Then what happened is, so in the response header, let's go over what response we got. So we got an HTTP. Remember, the request is using HTTP 2, so the response is going to come back as well with an HTTP 2. So again, the request and the response at that level, they're going to match. Then we have a few headers over here. Cache control. We're going to go over some of this. Content length. So the length of the response that we just got, right? So this is pretty much the Twitter website, the HTML content. The content type is text HTML. Again, this could have been MP4. This could be maybe a torrent URL, which actually brings the packets from many different sources. So it's a different type of a protocol. In this case, we're using HTML. The date when this was performed, any expiration for this, and then last modified. So if we're doing any caching, it's gonna say on it's gonna say, hey, cache this website. Again, we see here that has a header that says no cache, and then we see a few more headers that are setting cookies, right? And then we're gonna go over all this, and that's pretty much it, right? So we get a HTTP response, a few headers, and then after the headers we get the payload, right? So pretty much the response. Okay, so let's so that's pretty much what happens when we make an HTTP response, right? So the request, like I said, you have to specify the method. There's a get method, and there's a few. The most common ones are get, post, and put. Then the path, in this case, is the homepage. So we're just gonna put a slash, and then the version of the protocol. We can use over here HTTP 1.1, which still on the web a lot of websites use. But we saw that we already have HTTP 2, and I think HTTP 3 is even coming down the pike. So and then the rest that we the next thing we have to include in the headers in the request is any headers that we want to include. So the host developer.mozilla.org. So that's not optional. That's mandatory. So we have the path over here of what we want, but where, of what host? Well, okay, of mozilla.org. Okay, so we're gonna go to developer.mozilla.org, and then we want the homepage of that, and then that's what we're gonna resolve through the DNS, and then any other headers that we want to include. In the headers, we can include cookies or a few other headers that are pretty common, and we're gonna go over those as well. And then the response, it's again very similar to the actual request. It's going to bring us back what type of response it is. So the version of the protocol, right? The status code. So if it's a 200, it's like, okay, we got a response back. That was everything, everything went well. The status message, which is okay. Again, these two things can change, and depending on how they change, it tells us something different about the response that we got. And then any headers that want to be included in the response. So the response and the request, they both look very similar. And again, like you saw, there's not really a lot of magic. Anybody can create an HTTP client and start making requests to a server. So again, if we remember, the main model of the web is a client-server model, right? So the client adds the server for resources, and the server replies, right? It's pretty simple. It's human-readable text protocol. So if we look over here at Twitter, this is HTML, but essentially, you can just write from any text editor that you like, and you can just start kind of hacking away on writing HTML and then sending it over the wire. It's also extensible, so just add HTTP headers, and as you can see, there the more headers, and over the years we've kind of included more and more headers in the spec. But any header that a browser wants to accept, they can pretty much, or a client or a server wants to accept, they can just write it in. And as long as you know what the headers are and you send the header, then that client can respond and actually understand the headers. So it's not something that's written in the spec. Anybody can pretty much add any headers they want, and in this way we can make it not just something that's standardized, but also something that's extensible and something that we can grow depending on the needs of any individual client. It's also stateless, so two requests have no relation to each other. So remember, as we're sending packets over the wire, pretty much as you can see, the get and so the method, the path, and the version of the protocol, that's pretty standard. The host is pretty standard. So everything has to be included every single time we make a request. There is no state that we actually have embedded within the HTTP protocol itself. Now we can add it, and we're gonna go over one of the ways to do that, and cookies is one of the ways. But again, that's not something that's part of the protocol itself. That's just something we add to the protocol in order to actually have state and, for example, login or anything like that. And as we saw, because of this, we can perform certain attacks like, session hijacking and stuff like that. But again, it's not part of the HTTP protocol itself. It's something that we can just tag onto it. And it's a transport or protocol agnostic. So the only requirement is reliability. So, over the transport, you can pretty much send anything you want, right? In this case, we're sending a simple HTML document. But, as you can see on YouTube or any other video site, we have videos. You can send PDFs. You can send whatever you want. So it's pretty much protocol agnostic. And the web in the state it's at, it really serves a lot of extensions. So it's not just a simple document viewing platform anymore. It's become a lot more than that, right? So, like I said, now we mentioned that HTTP is stateless, but obviously we do interact with stateful servers all the time, right? So when we log into a website and we come back to it, and that site remembers our login information without us having to re-enter it, then how is that happening, right? So if we said it was stateless, but at the same time we know we log into different websites and the sites somehow remember that information. So again, we're going to get into that as we go into cookies. So stateless in this case means that the HTTP protocol itself does not store any state. Okay, if state is desired, is implemented as a layer on top of the HTTP protocol. It's not something that's baked in. Okay, so that's very important to understand. Now let's go over some of the HTTP status codes. And again, if I were you, for me, the first time I remember learning this, I didn't really know. Now as a developer, you get pretty used to some of these codes. You get accustomed to seeing one of them, some of them more than others. But I think it's helpful to understand, at least have a basic understanding of what each of them mean on the web. So we have the ones that are in the range of the 100. They're pretty much informational status codes. In the 200 range, there's success codes. So we saw that we get a 200 success okay. So that's pretty much when we make a request and everything goes well, and we get a 200 back. At 300, it's a redirection URL. So that tells our, when we're dealing with the DNS resolver, it tells the resolver, hey, this page has been moved, and you can find it over here. And then usually it'll tell the DNS where to go to find that page at that point. At 400 error, I think everybody's used to this, seeing a 404. This is on the client side, there was an error. And then a 500 error is on the server side. So the 400 and the 500, they're both errors on the resource that we tried to access, except that the only difference is that the 400 is on the client side, the 500 range are on the server side. So let's go over some of the success codes. 200, okay, it's the request succeeded. Here's another one that's common and you might see, especially if you're dealing with, let's say you're sending a whole video over the wire, and you want to start the video at actually minute 1. So there's no reason to send anything before that. So a 206 partial content request, you can do a partial content request for a specific byte range. And again, this is useful when you're dealing with large files and you only want to send in the packet from a certain byte range to a certain byte range, and then over a period of time. So as you're buffering in that video, maybe you start at minute 1 and then you start buffering in the rest of the video. But so the partial content byte range is useful for those contexts where we're trying to send over the wire something very large, right? You don't want to just send a gig over the wire, but what you want to do is maybe send intervals of 10 megabytes maybe, or something along those lines. Okay, then we have the HTTP redirection codes. We have 301, which means it's been moved permanently. So the resource has a new permanent URL. We have a 302 found, which means the resource has been temporarily resized at a different URL. So the main difference between the 301 and 302 is one is permanent, one is temporary. And then the 304 is not modified. So the resource has not been modified since it's been last cached. And again, the important thing to note here is that let's say something gets back at 301 and it says it's been moved permanently, then our DNS can cache whatever we get back from, we're going to go ahead and then make that next round trip and ask for that new resource based on what the 301 returned to us, and then we can cache it, right? So the 304 tells us, hey, that resource that you got back, it hasn't changed since last time, and then what we can pretty much do at that point is just hit the cache and not have to make all those round trips. Now, let's go over the HTTP client error code. So the 400 is a bad request. So it's a malformed request. Let's say you're coming over here and then you want to use HTTP version 14, and like let's say that doesn't exist. So it's gonna tell us, hey, that's not something I recognize. So it's yeah, so that's just it's just not gonna go through. Or let's say you're sending some information that the protocol doesn't understand, or you sent it in a weird way. So it's malformed. It's just gonna spit back. It's like the server doesn't recognize this, and here's a 400 error for you. So a 401 unauthorized. So this resource is protected, needs to be authorized. So again, this is not so much that you made a bad request, but you're trying to access something that at that point you didn't have access to. 403 forbidden. The resource is protected. So again, very similar to the unauthorized, except that the server says, hey, this is protected. So you're not getting access to it. It's not that it's necessarily you don't have authority. It's simply saying that they're just denying access to that resource with the 403 error. And then we get the 404 not found. So that means it's not so much a malformed request. It's just a request that resource you're trying to access. It's it doesn't exist. And again, we went over some of the attacks that can happen with this, but that's pretty much the this is one of the ways that we can mitigate those attacks on the server side. If you see that you're getting a bunch of 404 requests from a certain IP, or from or that they're formed in a very similar way, and you keep getting back these 404s not found, then that might be a clue that you're being attacked because the requests are someone's asking for stuff that is obviously not there, and they keep asking for it. So either you cut them off, or you figure out a way that you cut off that IP and then at that point you can shield yourself from that specific attack. So let's go over the server error codes. And again, this is more of the codes that you will see once you're doing the development, and as you're developing something. These are some of the error codes that you might be getting. So you might get a 500 internal server error. So maybe they're like the server is not online, right? And then you make the request as a developer. I know this has happened to me. And you see on the terminal, it's like, well, that's you get a 500 back, and you're like, well, what the hell's going on? Well, maybe the server's not online, right? You get a 502 back gateway. So the server is a proxy, and the backend server is unreachable. So very similar, except that the server is going through a proxy, and then the backend server, it might be offline again, right? So then you might want to redirect the user back to another server proxy, or back to another server that's actually online. A 503 service unavailable. The server is overloaded or down for maintenance. Again, this can happen if a DDoS attack is happening, or maybe you're just doing a simple maintenance, right? So these are some of the. If you see a 503 on the response of the request you made, then that's one of the things that can mean. And the other one that's pretty common is the 504 gateway timeout. So again, if someone asks for a very large file, and on your server you don't have a way, so let's say you don't have a socket connection open, right, or the connection times out, then it'll wait like, I don't know, like 20 seconds, 30 seconds, whatever the server specifies. So if the server specifies that after 20 seconds, like cut this off, right, like it's taking too long and we have other users to serve, so it'll just respond back with the 504, hey, that resource you're trying to get just took too long, and the server just wasn't able to get it in the allotted time. And then again, there are ways to get around this. One of them is that range request. So you're like, okay, well, you can set your server up so it doesn't send the whole gig over, right? So it doesn't load it into memory and then send it over. So the server you can set it up so it's set up in such a way that it's gonna send 10 megabyte files every time it gets it. So hey, as you get the 10 meg files, start sending it over. And what we're gonna do is we're going to reproduce that file. So we're going to just create that file piece by piece on the client side until we get the whole file, right? Until we send the whole 1 gig. But at least you don't get a timeout error, right? And at least you don't get a denial of service from the client's perspective. So you can still serve your users and send large files over the wire. So HTTP headers, right? So so again, now that we know what actually happens when we make that request, right? When we type in a URL and we press enter, The first thing, okay, is the method, the getter, then the path, and then the version of the protocol. But then we have this other section here that are called the headers. Okay, so the HTTP headers are very important in any request or response, right? They let the client and the server pass additional information with the HTTP request or response. So this is one way that we can have that stateful behavior that we're looking for. For example, we don't want a user to have to log in every time they visit our website. So maybe they log in once and then we send back a session ID, and with that session ID we can validate that they're the correct user, right? So that's one of the ways that the server and the client can send information back and forth, and we can keep some sort of state that's not included within the HTTP protocol itself, right? And they're essentially, the way they're set up, it's essentially a map of key value pairs, right? So you see the key over here, it's called host, and then the value of that, it's whatever you see on the right. So on the left side you get the key, accept language, and on the right side you see the value of that, which is in this case French, right? So and again, that's pretty much how they're set up. And again, one of the great things about headers is that they allow for experimental extensions to HTTP without requiring the protocol to change, right? So without us having to actually go through a committee, or the committee actually, coming to terms with something that they want to add to the spec, any client and any server can send or respond with any headers, and as long as they understand their headers, then HTTP kind of says, we don't really care. If you guys understand each other, then that's fine. So here are some useful HTTP request headers that you might come across. So the first one is host, so the domain of the server, right? And we saw that over here. So the host header, that's actually a one that's mandatory. The user agent. So depending if you're like searching from, let's say, Chrome or Firefox or Safari, that user agent will change, which is the name of your browser and operating system. Okay, and it's composed of those two things. So the refer, let's say you clicked on a link. So part of that request, when you click on one website and then go to another website because you clicked on a link, that request is actually going to have attached to it a referrer header. So that on the server side, if they want to track it, who's sending most of the traffic to them, that the referrer header, it's one of the ways that that's done. Also the cookie header. So you saw in the curl example over here, you saw that we can set we said that over here we have the set cookie. So over here Twitter is setting a bunch of cookies that eventually are going to that they're using for either, let's say, ambient authorities, so to check if the user is signed in or not. So again, setting cookies is another very common header. And then the range header that we spoke about. So in that sense, what you're saying is, hey, I just want a specific subset. I don't want the whole file. I just want from byte X to byte Y, and just fetch that for me, please. So that's what that is. Another one is cache control. So you can specify if you want something to be cached or not. Let's say a resource that you send to the user doesn't really change, the same image or something. So maybe you're like, hey, cache this image, because they're going to be asking for a lot, and we don't necessarily want to, every time we serve it, it's going to be the same image. So once they have it, just cache it. So that way the client knows not to ask for it again. And once they cache it, then they can just get it from the cache instead of asking the server constantly what that same image or that same resource that's not necessarily going to change. So if modify sends, very similar. So only send resource if changed recently. So again, we saw that some of the headers that the server can send, it said, it hasn't changed. So if it sends that header, it's going to say, oh, okay, great. So like, just get it from the cache then, like we're just going to send you the header back without the resource, because we expect that you have the resource in the cache already. The connection, so you can actually control TCP sockets. So this is one of the ways that you can keep a connection open. And again, maybe you've seen like WebRTC or something like that. So they keep a constant connection open. And in this way, you can have VoIP, that functionality of like video and audio from two different computers over their wire, right? And then keep that connection open for as long as like the conference or the call is happening. So that's the connection request header. the accept header, which type of content we want. So if we send that accept header and we're saying, hey, we're expecting back HTML, and we get back like something else that's not HTML, then we can know it's like, like that's not what we were expecting, and then we can just discard that. Accept encoding. So let's say we accept like gzip, and we're sending back kind of a large file, maybe a React application that's pretty large. We can gzip it, and as long as the client accepts the encoding of gzip, then all is well, right? So you can create this encoding header. Another one is accept language. Again, as you can see, these are not standards, right? But they're common, and but all that's necessary is for that client and that server to understand these two things, and pretty much HTTP doesn't really care at that point, and they're like, fine, as long as both the client and the server understand each other, then they can allow you to attach any headers to any request, okay, and to any response for that matter. So yeah. Okay, now let's go over some useful HTTP response headers. Date, so when the response was sent. The last modified, when the content was last modified. So again, these are pretty much self-explanatory, but as you're debugging and as you get more into web security, these are some of the ones that you really are going to come across, and they're going to be helpful to help you debug or find out where there might be potential vulnerabilities. The cache control header, so it specifies whether we want to cache a response or not. And again, we're going to go over this in one of the attacks that I'm going to show you. The expires header, discard the response from the cache after this specific date. So you can just delete a cookie or something along the line. So you can do it through the expires header. The vary, it's a list of headers which affect the response used by a cache. So we're gonna go over this in more detail as well. And then the set cookie header. So the actual response. So let's say you log into Twitter, and with that, and then let's say the login was successful. So then the server can actually set a cookie on the response that it wants. The next time the client makes another request to that same URL, it wants that cookie to be included, right? And then that was one of the ways that we were able to perform that not DNS hijacking, but cookie hijacking attack that you saw from the bank account, right? And then we were able, because the user had at some point logged into that bank account, and then an attacker was able to get a user on another website, and then behind the scenes they were running a post request to the server. They actually made an action that the user or the client in that case was not intended to, but the attacker was still able to perform it because the header, the server at some point sent a cookie back that said, hey, whenever you perform a request back to the bank, just include this this header, this cookie, and we know that you have already been logged in. So again, if someone gets access to that information, you can see how it can become very, very dangerous. Or in your website, let's say you have some information behind some paywall. So only people that are paying customers should be able to access that information, and someone gets access to a session ID or something, and then they take on the identity of that user. At that point, there's really nothing the server will see different, because all the requests, any client can make the request, and as long as in the header they include their correct information, then the server has no way of knowing that this was a malicious request. And then at that point, that person is kind of a host. And again, in the banking example, it's a little bit more clear why this is dangerous, but it can happen in any case. And pretty much anyone can take once they have access to your cookies or that session ID. It becomes very, very difficult to defend against it. So some more useful HTTP response header is the location. So the URL to redirect the client to. So again, if we get a 301 response, usually with that response, you'll get a location response as well that tells you, it's been moved over here. And then at that point, the DNS resolver will make another round trip and then try to get that IP address for where that resource has been moved. The connection, again, on the server and the client. So sometimes the client wants to keep the TCP connection open, but the server's like, no way, we don't want to accept that. So the server can actually also control that. The content type, the type of content in response. So again, very similar. If the client was expecting HTML and the server can actually specify that. So if there's any mismatch in those things, then then that can actually issue a one of the errors that we went over and say, this is not this wasn't what we expected back. So yeah, the content encoding, the language, and the length. The content encoding on the server side, it's again, let's say the client says, hey, you can send, if you have a JSON, send it back in JSON form, let's say. And the server's like, oh, you know what? We do have it in JSON. We don't have to send the HTML back, and perfect. And so they send it back in JSON response. So there's a way for the client and the server to communicate over what the information is going to look like. The content language, again, this is just a header that you can use for internationalization. So again, one of the ways that you can do that, and then on the server side, you know that if you get the content language header, that the server knows how to respond to that. And then the content length is the length of the response in bytes. So usually with this, you can say, let's say you're expecting something that's a certain length and no more than that. And then all of a sudden you get a file that's way bigger than expected. And then again, that should raise some red flags as far as, it's like, well, what's been included in this response that made the file so much bigger than it's supposed to be, right? And then again, it could be a code injection attack, or which we'll cover later with XSS. But again, that's another thing that you can look at for the content length. If you're expecting a certain length and then you get something different, then it could be a red flag that something was injected that was not supposed to be there. Okay, so that's pretty much for HTTP, and that's the second part. So when we go on the web, remember, the first thing that happens is we go through our DNS. Then the DNS, the way it's sending all this information is through the HTTP protocol. That's pretty much the way that we're going to be accessing resources online. And then what we're going to do in the next session, we're going to cover some of the big vulnerabilities, and we're going to start with cookies, and then we're going to move into different attacks.